All right, so today we are adding on to our special right triangle. So this is why it's called 5-8b. Let's start with the review on this. It says draw an isosceles right triangle. Label one of its legs 13, find the length of the other leg and the length of the triangle's hypotenuse. Go. You should have been done. I know that sounds really mean, but it's meant to be that fast of a problem. An isosceles right triangle, what should I label on my right triangle? The 45 degrees. Okay, so we're going to go 45, 45, 90. What else could I label on there before I did anything? Can I do my congruent legs? All right, if one leg's 13, which I asked you to write down, what's the other one? 13. What's your hypotenuse? Yeah, 13 times the square root of 2. Now that's your pattern. Now remember, I told you, make sure you memorize the triangle. I call it the generic triangle, but the triangle that causes the pattern. So if you have a 45, 45, 90 triangle, remember I told you to go x, x, x root 2. Now here's the reason why. Let's see if of course I closed it earlier today. If you take the PSAT or SAT, which by the way, I'm hearing rumors that we're going to start taking practice SAT exams as well as ACT on there. If you could do a math section on the SAT at the very top of it, I want my two vouchers right here. Do you see a 45, 45, 90 triangle? And you notice they go S, S, S root 2 instead of X, X, X root 2? They put it there to help you. You guys see that right there? The rest of you are like, trust them, okay? I'm not gonna walk all the way back there. But also next to it, Joe, do you see a 30, 60, 90 triangle? That pattern is what we're learning today. So it's actually on your standardized test so much that the SAT, which is what the College Board, the people who write the AP exams, they put it on the start of every math section for you. That's how important it is for us to have it memorized. Unfortunately, for the ACT, they expect you to have it memorized and they won't give it to you at all. So that's one reason why we got to get these down. So 45, 45, 90, do you guys think it was pretty easy? Now, some of you kept wanting to use the Pythagorean Theorem. Stop. If it's a 45, 45, 90, you don't have to. Okay, you don't have to. Really, for the Pythagorean Theorem, you always want to think, if I know two sides, then I know that I can solve for the third using the Pythagorean Theorem. But with a 45, 45, 90 triangle, use the pattern. All right, now let's develop another pattern. We're going to do this with a 30, 60, 90 triangle. Now, 30, 60, and 90, I think you guys would all agree with me, are three different sizes of angles. So shouldn't I have three different sizes of sides as well? Does the three pairs theorem tell us that? There should be a longer side, a middle side, and a shorter side, right? So we're going to figure out the pattern for that in this. But the one thing I want you guys to know is in order to do this, we actually have to use equilateral triangles. So every black triangle you see on the screen, that's your 30, 60, 90 triangle. Now, however, I want to make it to an equilateral triangle. So what I'm doing is I'm really taking that 30, 60, 90 triangle and I'm flipping it over, or reflected it over this axis right here. So I get another 30, 60, 90 triangle. That's exactly the same size. Does that make sense? And so then the whole triangle, the big one, ends up becoming an equilateral triangle. What do you guys think? Pretty simple? All right, so we're going to use that to help us out, the fact that we made that equilateral triangle. So with that, if that one side is 12, do you guys agree with me that this whole side is 12? Okay, what does that perpendicular segment in the middle of the big equilateral triangle do to the base? It bisects it, so these two would be the same. So wouldn't that be 6? Now, the only side missing on the, remember the little black triangle is really what I'm trying to work with and solve for the missing sides. I'm looking for this missing leg. So let's call that missing leg X. So I got my 12, I got my 6, I got my X. Can I now use the Pythagorean Theorem for what's missing? Yeah, so what do we say for the Pythagorean Theorem again? Leg squared plus... See, you all know the Pythagorean Theorem. Beautiful. So I get here 6 squared plus x squared is equal to 12 squared. I'm going to move that up. So I get 36 plus x squared is equal to 144. Subtract 36 from both sides. x squared is going to equal 108. Now remember, to solve this, I do take the plus or minus here, but what do we know at the end of the problem we're going to do? We're going to drop the what? The minus. We're going to drop that negative sign because we know it only can be a positive length. But I want to be able to simplify 108 because unfortunately it is not a perfect square number. But I can simplify it some. Does anyone know the largest perfect square number that comes out of 108? 9 is a good one, but it's not the biggest. It can go higher yet. 36, right on. So 36 times 3 is 108. That's one of those that you don't see often, but if you kind of remember 36 comes out of 108, it makes life a lot easier. So what's the square root of 36, guys? So really, my answer is going to end up being a positive 6 root 3. So this segment right here is 6 root 3. All right. Kind of see a pattern a little bit? All right, let's try another one. Doing the exact same thing, we're just starting with a different side of the of the 30, 60, 90 triangle. Wow. Okay. I'm going to cough or sneeze or something when I try to do a video. No matter what, I'm not winning here. Okay. But with this one, guys, we're going to then reflect it over, and I get a 30, 60, 90 triangle. Do you guys agree with me? The segment in the middle right here will bisect the side. So if this is going to be 4, what's the length of this whole side? Which means this whole side has to be 8. Can we use the Pythagorean Theorem again to solve for the missing side? Yeah. So again, we're going to go leg squared plus leg squared equals hypotenuse squared. Now remember, we're looking at the little black triangle right now, not the big one. The big one just helps us solve for side lengths. All right, so let's do it. What's 4 squared? 16 plus x squared equals 64. Subtract 16 from both sides. I get x squared is equal to 48. Can I take the square root of both sides, guys? All right, so I get plus or minus the square root of 48. Again, why do I do this? Your guys like, Gregerson, you're so annoying. You keep putting a negative there, and we know it's a positive answer. It's because, what if it's not a triangle? Could I have a negative answer? So remember, we're trying to keep this so we learn context, but also so we do our math right when you go into Algebra 2 next year. I'm trying to help you out. So with this one, what comes out of 48? Yep, so it'd be 16 and 3. Guys, what's the square root of 16? So is this going to be 4 root 3? So that side's going to be 4 root 3. Pattern, anyone? We're starting to see one? All right, how about if we try to make the pattern that we're going to use on the generic triangle by just using variables? All right, push ourselves just a little bit. I'm going to do the exact same process as the last one, because this time, instead of saying that side is 4, I'm going to say that it's x. So again, we're going to reflect over, so that way I know this whole side is the side of the equilateral triangle. I still know that segment in the middle will bisect it. What's the length of the side? 2x, that's right. So it's x plus x is 2x. Yes. Do you have 5 on yours? Oh, you have a 5 on yours. Oh, this is better. The numbers work out nicer. I think I loaded the wrong one down on there for you guys. You actually have a nicer one on this. Oh, well, make sure if I have another mess up like that, tell me. Are you guys with me on this? So to me, 5 here? All right, good. This actually is nicer to use the numbers. I think you'll see the pattern better.
Are we going to have the other?
No, I was just using the variable to show you the pattern more than anything. So no, you're good. Most of it's just like yesterday. Solve for the 2 sides that are missing kind of scenario. All right, so we have 5 and 5 here. So what do we get? 10? All right. Can we do the same thing and solve for the missing side? What do you guys think? Yeah, no? All right, so what do we get here? 5 squared plus x squared equals 10 squared. So 25 plus x squared equals what, guys? 100? So what's x squared going to be? So I'm wondering if I put the right one in yours. Hopefully I did. Hopefully I did. All right. So with this one, you should get 75. Guys, what's the square root of 75? You should know this one by now. 5 root what? 3. Because if not, it's okay to write this out, but we want you to get to the point when you're simplifying some of the basics, like square root of 50 or square root of 75 or the square root of 32. We want you to be able to recognize those quickly to solve. But x is just going to be 5 root 3. Okay, much better than what I was going to create for you guys to do, so sorry. All right, so with that, what's the pattern? What's the pattern? Don't look at the next page. I want to know it from this one. What is the pattern? You said hypotenuse, you said is leg times 2? Close, but I have 2 legs and they're 2 different lengths. So close. Could we say short leg times 2? Isn't it the smallest of the 2 legs? All right, so hypotenuse you said is, we're going to say short leg times 2. Okay. Now, what do I know about the longer leg, the one that has like the 6 root 3, 4 root 3, 5 root 3? What you got? Smallest leg times. All right, so the longer one, because that's the one that's opposite, is really just the short one times what? Root 3? All right, well, that's exactly the pattern. Look at your theorem. In a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg. The length of the longer leg is the length of the shorter leg times, should be times, excuse me, root 3. Now, what in the world am I talking about? This is using the idea of 3 bears, right? There's 3 different sides to that triangle lengths because we have 3 different angle measures. Always opposite the 30 is your short leg. I don't know why it doesn't want to write down, so we're going to rewrite that. So this is going to be your short leg. Opposite your 60 is going to be your long leg. And then your hypotenuse, guess what it's going to be? Hypotenuse. Now, again, I'm using the same term as before. I want the generic triangle. I want to do it with variables instead. You guys just said everything's based off of the short leg is basically what you just told me the pattern was. So if I said the short leg is x, so we're going to call this x. What's going to be the long leg? What did they tell me for the long leg? The length of the longer leg is the length of the shorter leg times. So this is going to be x times the square root of 3. Now, what about the length of the hypotenuse? What did it say at the beginning of the theorem? 2 times the short leg. Notice it's everything based off of the short leg. Basically, think of it as home base. Those of you who are competitive, you remember all those tag games as a kid? If you were on base, you were home, you were safe. You're safe if you always use the short leg. You're not safe if you use the other anything else. You want to go home. If you don't know the short leg, you go home to the short leg. So no matter what side I know, always find the short leg because that's what I'm going to use to calculate the other 2. And again, some of you are more a words type person, so you can write the equation out, but you can also say long leg is just short times root 3, and the hypotenuse is just 2 times what? 2 times short leg. So another way of doing those. Know this triangle. And this was interesting. If people let me put it this way. If people memorize this wrong, they're going to get it wrong. And I'll tell you the number one thing that they do. They switch the short leg and the hypotenuse around. Remember the square root of 3 is smaller than 2. Because the square root of 4 is what value? 2. So make sure you get the hypotenuse correct. All right, are you guys with me on that? So let's do this real quick. Let's just practice solving for this. And now, again, because I moved this up, I'm going to draw the 30, 60, 90 triangle here. Short leg is always opposite which angle? What is the short leg is always opposite which angle? The smallest angle, so it has to be opposite the 30. So that's your short leg. So don't forget that. So we have our short leg here. It's going to be x. My long leg is x root 3. My hypotenuse is 2x. Rules like yesterday that are the same. Smaller to larger, you multiply. Larger to smaller, you do what? Divide. So look at the first one for me. Is that a 30, 60, 90 triangle? Okay, and then ask yourself, what side do you know? You know the hypotenuse. Which side do I want? Where do I want to go? Home. What's my home base? Short leg. It's this one, correct? So my question is, how do I go from my hypotenuse down to the short leg? Divide by what? Divide by 2. All right, so do that. X is just 22 divided by 2. What's that going to be? Someone goes, can I do that in my head? And can I just write 11 down? Look at me right now. Because normally I'm like show work for everything, right? If it's that easy, put the answer down. Did you hear what I just said? That one's so easy, please do. Now, I still need to get which side? So I can get to the long leg. So how do I go from short leg to long leg? Do I multiply or divide? What do I multiply by? Root 3. All right, so y is going to be 11 times. Well, we're done. Anyone want to go back and use the Pythagorean Theorem? Isn't that faster? Now, I can't do that, though, if I didn't have a 30 or 60 degree angle there. Just let me know it's a 30, 60, 90 triangle. All right, next one. Not as pretty of an answer, but very doable. Is it a 30, 60, 90 triangle? All right, what side of that 30, 60, 90 triangle do you guys know? You know the long leg, right? Now, be careful to say long side, because the hypotenuse is the longest side. So long leg. It's just so you know, quicker way of saying that. So hypotenuse, though, is y. So I got the long leg. I got to go home. How do I go from, now we're going to go the other way, right, guys? How do I go from the long leg down to the short leg? Multiply or divide? Divide by what? Square root of 3. Awesome. So x is going to be 15 divided by the square root of 3. I'm done. No. Do we have a radical in the denominator? So, oh, look at that, Jack. That's done correct. Good job. All right, rationalizing the denominator. High five him for me. Thank you. All right, so we get 15 root 3 over what, scholars? What, square root of 9 is what? 3. Am I in simplest form yet? No, because the 15 and 3 can simplify. So I end up getting here 5 root 3. So there's your answer for x, 5 root 3. Okay, I have home base. Can I quickly now get to the hypotenuse? Multiply by what? 2. All right. So what I'm going to go here, y is going to equal 2 times 5 root 3, which gives me what? 10 root 3. Again, someone goes, can I do that in my head? Look at me. Yes, yes, you can. If you realize you're just doubling the 5, isn't that pretty fast? The mistake is if you try to double the root 3. Don't do that. It's the number out front. What do you guys think? Not too bad? But you have to memorize the pattern. All right, let's look at C here. What's my pattern here? Is it a 30, 60, 90? Okay. Remember, ask yourself, do you know the short leg? Unfortunately, do I know the short leg? No. And I need to find it. But what side do I know? All right, we have the hypotenuse. All right, so with the hypotenuse, can we go hypotenuse to short leg? Multiply or divide? Divide by what number? Can anyone just do that in their head for me? That's 9 root 3. Now, if you need to, could you write out an equation like hypotenuse equals short times 2 or 2 times short? Let's do it that way, 2 times short. If you wanted to, could you go hypotenuse is 18 root 3, then I got 2 times x because my short is x, and then solve it as an equation? Would you still get the right answer? To me, that's just a lot more work than doing it in your head. But if you don't do it well in your head, does it pay to write that out? Yes. All right, talk to me now. I have the short leg. I need to get to the long leg. Do I multiply or divide? Multiply. What do I multiply by? Oops, gotta make sure I get my battery here. What do we do? Yep, multiply by the square root of 3. Awesome. All right, so let's multiply by the square root of 3. All right, to get to y, we're going to go 9 root 3 times root 3. That gives me y equals 9 times the square root of 9. Guys, what's the square root of 9? 3 times 9? 27. Now, listen to me, guys. A problem like that you could easily have to do on your quiz tomorrow. So make sure that you're on top of these. Let's keep going. I want to keep cranking these out. Talk to me on D. What side do I know? Short leg, long leg, hypotenuse? Short. All right, so our lives just got really, really easy. Yeah, the nice thing is we didn't have to solve for the short leg first. How do I get to x? All right, multiply by root 3 because I'm going short to long. Again, if you need to, always redraw your 30, 60, 90 triangle down so you can see the pattern. So I'm going to multiply by root 3. So x is just 5 root 3. Guys, what's y going to be? All right, please don't say 10 root 3 because that would be wrong. Because remember, we always have to go off the short leg. So that's going to be 10. Shucks. Right? It lets me know if you know the pattern. Talk to me on the next one. Isla, what do you know? Short leg, long leg, or hypotenuse?
Long leg.
Long leg. So I need to go home base. Guys, I got to go home. I got to go to the short leg. So how do I go long leg to short leg? What do we do? Yep, divide by the square root of 3. Now, there's a reason why we worked on rationalizing denominators. It's because of 30, 60, 90 triangles. Okay, that's really the reason why. So we rationalize the denominator. So I get 9 root 3 all over 3, which makes that 6 or 3?
3.
Yep, 3 root 3. All right, so this is 3 root 3. All right, guys, how do I get to x? Multiply by 2. So 2 times 3 root 3, which gives me? Does anyone want to go back to what we did on the very front page? Because that's what we'd have to do otherwise. I like this better. All right, next one for F. Is it a 30, 60, 90 triangle? Because all they put is n, 2n, and a right angle. I can't do these patterns if it's not the case. What if that said n and n? Wouldn't it be a 45, 45, 90? But instead it's n and 2n. Well, guys, what does n plus 2n add up to? 3n, which adds up to 90. So 3n equals 90. 90 divided by 3 gives you 30. Wouldn't that be a 30 and a 60 then? All right, work for me. Guys, where's your short leg? Is it x or y? All right, so we got our x. Great. What's the value of that? Hypotenuse to short leg. What do I do? Again, if you need to write it out, you got 2 times short, right? Hypotenuse is 2 root 3 equals 2 times x. Can I divide both sides by 2? X equals root 3. A lot of you are like, I can do that in my head. Good. Okay. How do I get to the long leg? Multiply by root 3. So I got root 3 times root 3, which is square root of 9, which is 3. Make sure it's square root of 9, which is 3. All right, let's try with this people sitting next to you, please. I want you guys to do these problems. And make sure that I want to make sure I got the right ones. Okay, good. I think the rest of my notes match yours, so this is a good sign. Okay. Do them with your partners. All right, I put the first 3 up here. How did you guys do on the first 3? Did we get it? Now, some of you are starting to catch how it works best for you. Like, I was talking to Bethany, and she's like, I just have to mark what's the long side, hypotenuse is short, and then she knows she can do the math with no problem. That's brilliant to know that about yourself. Some of you are always going to have near you, no matter what, you're going to want to put your 30, 60, 90 triangle down. You're just going to put the generic triangle. Some of you are going to do like I did the C with, using the equations. The words that I had like below the triangle in the theorem might work best for you. But no matter what, just have your stuff down. Then I was mean because then I gave you D and E. And then D and E, actually, if you look at D, is there really 3 triangles that you're looking at? Yeah. The 2 smaller one and the bigger one. And then wasn't it really kind of just, I don't think it's cruel. I just think it's brilliant on my part. There was a 45, 45, 90 triangle. Now, the thing is, I want to know 4 segments. Like I said before, this has shown up on finals before, quizzes, tests, all that good stuff. You've got to make sure that you can just think it through. A lot of you did, which I was so thankful. A lot of you sit there and said, Gregerson, I'm going to ignore this triangle for right now and look at the one on the left because that's what type of triangle? 45, 45, 90. And I know that's an isosceles right triangle. Well, if you need to, couldn't you just draw your pattern for an isosceles right triangle right above it? And what do I know for that 45, 45, 90 triangle? Hypotenuse or leg? Hypotenuse. How do I go from the hypotenuse down to the leg? Divide by what? Root 2. So can I just say 7 root 2 divided by root 2? Oh, look what happens to my root 2's. Goodbye. So I get C is equal to 7. If C is 7, what's A? Now, can I basically ignore the triangle on the left and look at my triangle on the right, which is now what? A 30, 60, 90? What side of that 30, 60, 90 do I know? Yeah, isn't that going to end up being, I don't like where that 7's drawn. Here we go. Or not work. Watch it freeze on me right now. Yeah, it is. Isn't this my short leg right here? Can I get to the long leg, which is D? What do I multiply by? Short to long, multiply by what? Root 3. Isn't that going to be 7 root 3? If I know the short, how do I get to the hypotenuse? Multiply by 2. So 2 times 7, isn't that 14? So what do we get here? C is 7, A is 7, B is 14, and D is 7 root 3. Was that really that hard?
No.
But do you have to know the two patterns?
Yeah.
Yeah, for both of them. All right, talk to me on this last one here. For E, which triangle am I going to work with? One on the right or the one on the left? The left one? Okay, what type of triangle is the left one? 30 to 60, 90. So don't I need to find home base first, my short leg? All right, so what do? Divide by what? Divide by 2, okay. So to C, I'm going to go 4 root 3, divide by 2. What do we get? 2 root 3. Awesome. So this is 2 root 3 right here. So that's C. How do I get to the long leg, which is A? Short. No, careful. Short to long leg, I multiply by root 3, right? So it's 2 root 3 times root 3. All right, that gives me 2 root 9. Well, what's the square root of 9? 3. So isn't that 6? So A is 6. Can I use the triangle to the right now? Is that an isosceles right triangle? Guys, what's D going to be? 6, because the legs are congruent, so that's 6. Guys, what's B, the hypotenuse of the isosceles right triangle? Leg to hypotenuse, multiply by root 2. There you go. But do you have to know my patterns? Yeah, know your patterns. All right. Now, wouldn't that be nice if that's all you ever had to do with 30, 60, 90, 45, 45, 90 triangles? Right? Do you think it's going to stay that way? Go to the next page. Go to the next page. Our next unit is going to be solving for area, and we have to use 30, 60, 90 triangles and 45, 45, 90 triangles and solving Pythagorean Theorem. So then you're going to get stuff like these two. Now, on this one, you guys agree with me that both of those are just trapezoids? Okay, so we have two trapezoids. We have our bases and we have our legs. I want to find the value of the variables. So on the first one, I don't know if you want to call that A and H or A and B, but I'm just going to call it B here. I need to be able to find that. Any suggestions? Yeah. Let's split it into, I'm going to do a little bit different than that. How about if we split it into a parallelogram and a triangle? So is there, because any 2 points determine a what in geometry? A line. So can't I draw it so my points make a right triangle, which voila, makes a rectangle. And notice I strategically drew how I drew the segment, right? I did it so I'd have a right angle. So when I do that, do I get a 30, 60, 90 triangle over here on the right side? But can I also use the fact that opposite sides of a parallelogram are congruent? So I'm going to use that to help me out. Because if I have 2 root 3 on that far left side, doesn't that become the long leg 2 root 3 of my 30, 60, 90 triangle? And with a 30, 60, 90 triangle, do I still, no matter what, always have to find home base right here? Well, guys, how do you go from long leg to the short leg of a 30, 60, 90 triangle? Divide by root 3. Okay, so I got 2 root 3 divided by root 3. Did that just become 2? Can I use that now to finally solve for one of our variables? Yeah, I have short leg to hypotenuse. How do I get from short leg to hypotenuse, guys? Times 2, which gives me what? Yep, so 2 times 2, that's going to be 4. So A is equal to 4. Okay, So we use the right triangle now to solve for one of the variables. We got a to be 4. But unfortunately, I need to still solve for b. But can I use the fact that this whole thing was 6 to start with? What did I use up from my base, my little short leg over there, my home base? 2. What was left for this one? B is equal to 4. I can use the idea of sum of the parts equal to the whole and work backwards. And I also use the fact that the opposite sides of a parallelogram are congruent. So basically, are we pulling in quadrilaterals and special right triangles now? Now, something that would be very easy to do is actually do the perimeter of that. And I think you have a couple of problems like that on your homework where you have to find the perimeter of a figure. All right, guys, can I do the same process for B? This time, it's still a trapezoid, okay? I'm still going to draw it strategically so I get a right angle right here in order to create a 45, 45, 90 triangle. And I'm pretty sure most of you agree with me that would be true. What side of that 45, 45, 90 triangle do I know? The hypotenuse. Guys, on a 45, 45, 90 triangle, how do I get from the hypotenuse to the leg? Divide by root what? 2, okay? So here I can go 3 root 2 divided by root 2. Does that equal 3? So does that become 3? Oh, look, what's A? 3, okay? Now, can I use what I've learned so far to solve for B? Guys, do you agree with me that these two segments are the same? So I know that's 4. This one's 3. Can I find the length of B, which is the whole thing? What's 3 plus 4, guys? 7. Isn't that just using the idea of sum of the parts equal the whole? All right, so we know here A is equal to 3, B is equal to 7. I don't know about you, but those aren't pretty looking diagrams by the time we're done. But if you're stuck, should you redraw and mark up your diagram? Totally. Some of you have electronic books. Have you figured out how to use your snipping tool on your Surface to like cut and paste the diagrams into your homework? Oh, if you have an electronic book, I'll show you sometime. You don't have to ever have to draw a diagram again. It's beautiful. All right, yes. Well, what's the length of this one right here? 4, right? 4,
I
3.
thought you were only that.
No, it looked like that because we drew our stuff in. But back to the original problem, it was the whole side. So that's where it's hard. You have to always kind of know what your original is as well. All right, so Ryan, stay focused with me here, my friend. All right, the next one. Find the perimeter of the given figure. So I'm asking for the perimeter of that triangle. Someone have a suggestion for me? Out of all the sides? Good. What's the only problem? I don't know all the sides. Or do I? Not yet. But can we use what we know? Can we use either our 30, 60, 90 triangle, or could we use our 45, 45, 90 triangle? So either one of the special right triangles. So looking at that, isn't that just a 30, 60, 90 triangle? What side of that 30, 60, 90 triangle do you know? All right, so that's your hypotenuse. I need to get to the short, don't I? How do I go from hypotenuse to the short? Divide by 2. So what's 6 root 3 divided by 2? 3 root 3. Okay, so that gives me 3 root 3. Awesome. So that's the short. How do I get from the short to the long? Multiply by root 3. All right, I heard it. Good job. So 3 times the square root of 3, what do we get? So 3 root 9 reduces down to what? This should be 9. Remember, root 3 times root 3 is what number actually? 3. So 3 times 3 is 9. Now, perimeter though, we have to add all the sides up. So I got here 9 plus 6 root 3 plus 3 root 3. Is that in simplest form? Not if I have terms I can combine. So do you guys agree with me? Since they both are in simplest form and they both have the same radical, can I combine those two? So I get the fact that's 9 plus 9 root 3 units. All right, good stuff. Talk to me. What do you know about B? What type of shape is it? Yep, it's a square. Now, did I draw the diagonal in? All right, if I draw one of the diagonals in, that square gets divided into 2 types of triangles. What type of triangles are those? Yeah, the isosceles are right. The 45, 45, 90. So these actually become 45, 45, 90 triangles. Can I use that to solve for the side length of the square? All right, guys. So if I look at just the 45, 45, 90 triangle, I know the hypotenuse. How do I get from the hypotenuse to the side? How do I go this way? What does it say here? Hypotenuse to the leg. What do I do? Divide by square root of 2. So I'm going to go here, 24, divide by the square root of 2. Got to rationalize our denominator. You get 24 root 2 over 2. I get 12 root 2. Is that what you guys got? But what do I know about that 12 root 2? Is it all four sides of that square? So if I do the perimeter for that, that's just 4 times 12 root 2. I get that to be 48 root 2, and that's going to be in feet. All right. That type of stuff, more likely to see like on a standardized test. Your test coming up, I don't think we put one like that on your quiz tomorrow, but that is something that could easily show up on the test. Are you guys with me on that? Okay. Makes sense? What time do you get out of here today? 25? Do you want to see your test? I can give them to you. You can just look them over. No, yeah.